Hello everyone. In this video we are going to determine whether the following equation is an identity. So an identity is an equation that will always be true no matter what choice we make for the variable. For example, if this happened to be an identity, then any choice for the variable theta would simplify to something that is true. So to determine whether an equation is an identity, the strategy we want to do is rewrite it using algebra and past known identities so it becomes obvious whether the equation is true or false. So what exactly constitutes obvious depends on how many identities you already know. However, if you have an identity, you can manipulate it and rewrite it and you'll end up getting something like 4 equals 4, which is obviously true. Or we might be able to take an equation, and if it's an identity, we could rewrite it and get something like cosine squared of theta plus sine squared of theta is equal to 1. And we know that this is an identity as well. So if we have an identity, we can rewrite it and get something that's either true or another identity, which is also true, and that will confirm it. So we want to check whether this equation is an identity. What we want to do typically is look at both sides and then work on the side that's more complicated. So if we look at this equation, the left side looks a little more complicated with that input there. So we want to try and reduce the complexity of that input. And so we have to think about what identities we already know. And one thing that you might know is that cosine of theta plus pi happens to be equal to negative cosine of theta. So if you shift the input by pi rotation, which is equivalent to 180 degrees, you get the negative of the cosine of just that angle. So we can use this on the left side. However, there is a problem in that what we have in the equation above has negative theta minus pi. So we need to find a way to get rid of that. So what we can do is we can actually factor within the input. So we can actually factor out this negative 1. And after we do that, we get theta plus pi in the center. We want to use another fact about cosine. So cosine happens to be an even function. What this means is that if you give it a negative input, you will get the same output if it were positive. In other words, cosine of negative theta is equal to cosine of positive theta. So what that means is that the negative sign we have here on the input, we can get rid of that because cosine is an even function. So that can be rewritten as cosine of theta plus pi. So we have cosine of negative theta plus pi is equal to cosine of theta plus pi. We can now use this identity over here, and we know that we can replace cosine of theta plus pi with negative cosine of theta. Now negative cosine of theta, that negative there can be pulled out to the front. So that's negative cosine squared. And if you're paying attention, you might notice that this is the thing that's on the right side of our original equation, right? So we started out with an equation. We wanted to see if it was an identity. We used algebra, the factoring, and a couple of known identities, and we ended up getting negative cosine squared of theta is equal to negative cosine squared of theta. So that means that the equation that we started with is also an identity because we've rewritten it into something that is obviously always true.